Okay, guys, today inshallah we're gonna start in section 1 of chapter 19. So we're still talking about astronomy or the space, and we're discovering a lot about different objects found in space. So in the last chapter, in chapter 18, we already studied the origin of the science astronomy, and then we studied also what are the tools that scientists could use, like telescopes, telescope, and so on, to study the space. Now we're just gonna talk in details about certain objects in space, when we're gonna start by the biggest and the most bright object, which are stars. Okay. So of course, when you are young, you know the famous song that "Twinkle Twinkle Little Star." You know it, guys. Guys, wake up.
Yes.
You know this song?
Yes.
Can you sing it?
Yes.
Can you sing it? Still sleepy. Okay. So here we said that in this song, you just ask a very important question. Okay, that's how I wonder what you are. What are the stars? That's a question that always when we are young we keep asking this question, and actually some people of you may still asking this question. What are stars and what they are made of, and why they look bright? Do do they move? Okay, and so on. A lot of questions about stars. So in this lesson we're gonna try to answer these questions together, okay? And we know a lot about stars. So first object, okay, we're just gonna talk about the color of stars, okay, as the first thing that we could observe once we look at the sky. For example, here at night, okay, once you look at the sky, for example, you could observe these two stars, okay, the Betelgeuse, okay, and Rigel. So these two stars, they represent the two corners of Orion constellations. Okay, what do you observe? What the difference between these two stars? Okay,
The color.
the color. Okay, so Betelgeuse it appears in the orange color, while for example Regio, okay, it appears in the blue color. Yes. So as they have different colors, okay, what does it mean, or what do you expect about these different colors?
Their temperature.
So their temperature actually somehow is different, good, and also that their composition, their structure, what they are made of. Okay. So actually here, that's a good thing, okay, as your friend said, temperature. So sometimes when you look at a flame, okay, for example, once your mother is cooking, okay, and you look for the butane flame, okay, in your home, you're gonna find that the flame has different colors, and the color could vary, red, orange, sometimes blue, and so on. So what are these different colors? Actually, these different colors represent different temperatures, okay? So for example, here when we look at this candle and this Bunsen burner or Bunsen flame, okay, and you find that here the flames appear to be in yellow or orange color, while this one appear in blue. What do you think? Which one is hotter? Okay,
The blue.
the blue one. That was expected, guys. Is it expected?
No.
Actually, it's not expected because always we think that the red and the orange current, they are the hot colors. They reflect that the object is hot, while the green or the blue, they consider to be a cool colors, okay, that represents it. So always that's what related to our minds. But actually, in real life, okay, or as a science, it's completely the opposite. We find that the blue color, okay, is considered to be a warm color. That's mean objects that reflect or emit the blue colors always they have higher temperature than the one which have the yellow or the orange color. So that means we could easily predict that the region, okay, has higher temperature than Betelgeuse, okay. So here that's the difference. So the first thing that regarding to the color of the star, we could predict, okay, we could know it's approximately temperature, okay. So like this region is higher than the Betelgeuse because it has a blue color, while this one has this orange color. In our question till this point, guys? In our question here?
No.
Okay, so like this, okay, that's the first thing we could just observe about the star, okay, its color, but we still have a lot of things that we could. So after, as we said, this color could reflect that they have different temperature, and as they have different temperature, so they suppose they have different structure or different composition, because this temperature is just a reflection for what kind of reactions, okay, that happens in between the different elements in that star to produce this amount of energy in different colors. So here that leads us to another question. What is the composition of star? What are stars made up of? Anyone have an idea, guys, what are stars made up of? Anyone of you have any idea what a star is made up of? For example, our sun. Yes, first made of gases. What are the most important gases that we could find in a star? Anyone have an idea? Like for example, our sun. Good, hydrogen and helium. Brilliant. Okay. So actually, okay, we could find that different stars, they contain different elements in gaseous state, okay, or they found in the gaseous form. Whatever these elements, but the most abundant elements that are found in stars are hydrogen and helium, like what found in our sun, okay. But we could find, okay, the other elements that found in form of gases. These gases actually they are gonna combine together, or they are just mixed together and make two layers. That means a star is made up of two layers: the core or the inner layer, which is high density, okay, in which the gas is found under pressure, so they somehow they are holding each other, and the outer layer in which the gases somehow are a little bit free, okay, or they are cool gases. So we could find that here in the inner or the core of the star, there is a kind of nuclear reactions happen between these gases, which lead to the emission of energy in form of heat and light. And once this light or these radiations come out from the core, they passes by the outer layer of the star. And as the outer layer of the star is made of cool gases, they absorb some of these radiations or absorb certain wavelengths. That means they absorb certain lights or certain colors of the radiations that got already emitted from the star. That's what make each star has different color or has different radiations or different temperature, okay, based on the structure and what is absorbed or what the kind of wavelengths is absorbed due to the outer layer or the composition of its outer layer. Is it clear here, guys?
Yes.
So, like this, regarding to what we said, we could find that, for example, our sun's, okay, here the star or the biggest star which we could observe in our atmosphere. So you could find this sun. What do you think? Is it hot? Okay, that means is it hot? Okay, the star, or somehow it's hot, not that much. What do you think regarding to its color?
Average.
Not much, okay, or that's not that hot because actually its color is yellow, orange, or something like this. So that means we still have, or there are other stars, okay, that have higher temperature than our sun, okay. So here, like this, guys, that's the first thing we know, okay. The composition of the star is, sorry, the color of the star, how it indicates temperature, and then we know the composition of the star or what our stars made of. What make one star different than other is the combination of elements or the mixture of the elements that found in that star, because not all the stars has exactly the same elements. Some stars may contain contain elements, and the other stars may contain different elements. So that's why make each star different than the other in the composition, and of course in the radiations or the energy that was going to be emitted in form of heat and light. So here let's find the color of the light which is already passing off the star. As a star emit radiation, that radiation is gonna be emitted in form of electromagnetic wave, which we could detect it as a light waves, okay? So in normal way, we know that our light wave is made of spectrum colors. Do you remember this, guys? How many color in our spectrum, in the white light or the sunlight, how many spectrum color?
7.
7, good, okay. Anyone can remind me what are the 7 colors?
Red, orange, yellow, green, blue, indigo, and violet.
Brilliant, Farah. Good, okay. So they are the 7 spectrum colors, or we call them the rainbow colors. So actually, the visible light or our white light, the light that we could receive from the sun, okay, that once we get a glass prism and allow this light, do you know the glass prism? Okay, I'm gonna just draw it for you. So here, this is a glass prism. Actually, it's a piece of glass, has a specific shape like this, okay. That is a glass prism. Okay, once the white light or the sunlight passes, it's gonna be separated, okay, or into 7 spectrum color. That means I could find that the light will divide into 7 different colors. Okay, of course, each color represents certain wavelengths and certain frequency. That means represents certain amount of energy, which means this sunlight is a combination of different amounts of energy. They are combined together, and I could spread them by using this prism. So the same that which we could have predict about the light which is already emitted from the stars. It's already like a one continuous light. We call it a spectrum, but actually this spectrum is made up of millions of colors, okay? So they could be, for example, our here we could red, orange, green, yellow. That what we can detect or our eyes can detect. But also we could detect another colors by using certain or sensitive sensors and tools. Okay, they could detect another wavelengths. Okay, so the same as we said here, we could find that the continuous spectrum or the spectrum, that means the combination of these colors together, which is are emitted from stars, okay, they contain a lot of colors inside. We could detect these colors by using some device or an instrument we call spectrograph. So what is a spectrograph? Actually, spectrograph, that is a device which is used to break the star's light into spectrum. That means break it into different colors, okay, or different wavelengths. So here like this, okay, once we do this, we could find that each star is gonna have different spectrum than the others. So like that will give us an idea about what is the combination, what is the structure of that star, what are the gases that in. To make the idea easier for you, we're gonna just get an example for this. Do you know the new signs which are used as a kind of advertisement, okay, on different malls or shops or something like this? Okay, you know that like the one which say welcome and you find it in red color, sometimes turn to blue, then turn to purple and so on. You know these guys?
Yes.
Yep. So actually, these signs they contain okay neon gas, or sometimes they contain argon, xenon, different noble gases they are included in. What is special about these gases that once they are exposed to the electric current, they make the atoms of these gases to be excited. So once the atom to be excited, their electrons start to pass to higher energy levels and then turn back. That cause radiation, or that cause the gonna emit some kind of energy in form of light. So each gas of these, once it becomes excited by the electric current, it produces different color. Okay, give different colors. So that's what make them okay interesting and funny, and they have different colors, and you could see it. It's somehow attractive. So the same idea, okay, we could use it here. So, but we find if we, for example, we get this neon or this kind of advertised lights, and we start to use it by use a spectrograph to find what are the colors that found in this light. So we are gonna find that each one has a certain okay colors in certain orders. We call them emission lights or emission lines, as you can see here. For example, you can see okay that's if we have the neon gas, and that if the hydrogen gas is used, that's helium and that's sodium. As you can see, no two elements have the same emission lines. It's like a fingerprint. So like this, it's once I see this pattern of emission lines, I could know that it's sodium. If I see this pattern of emission lines, I will know it's helium, and so on. You get the idea, guys? These are the emission lines. Is it clear for you?
Yes.
Yep. So each of these emission lights, for example, this emission light represents the purple color or violet. This one represents the orange, the yellow, the blue, and so on. So these emission lights, actually, each emission light represents certain wavelengths or certain color, okay? So that's the colors which are given once the gas is excited or become hot and so on. So here, that's the same idea. We could use it for stars. If we could use the spectrograph just to detect what are the emission lines that will be produced by the star, I could know what are the gases that found in the star. You get the idea, guys?
Yes.
Yep. So like this, the light of the color or the color of the light that is produced from the star could be analyzed by using the spectrograph to determine what are the emission lights. So that means once I know the emission lights or emission lines that are produced, I could know what is structure. But actually, there is a little difference in the case of the star. What the little difference? The little difference, as we said, that the star is surrounded by They're cool gases, or the outer layer, which is made up of cool gases. We call them the atmosphere, or the atmosphere of the star. And as we said, these cool gases start to absorb some of the radiation or some of the energy which is produced from the star. Do you remember this, guys? Guys, we just said this. Do you remember this, or you just forgot?
Can you re-explain it?
Okay, again, here, just as we said in the beginning of the lesson, okay, we said that the star is made up of two layers, the core or the inner layer, that which is contained the different combination of gas, like for example helium and the hydrogen, and they have this kind, maybe contain some of neon, okay, or some of these. They are different gases. They are reacting together. Once they react, they start to produce energy in form of electromagnetic wave. That means they are going to produce energy in form of light and heat. But once they pass from the inner layer, there is another layer outside, okay? This layer outside, which is the star atmosphere, okay? So this star atmosphere is made up of cool, okay? Cool gases, okay? So these cool gases, actually, they are gonna absorb some of these radiations. That means, for example, they will not allow this to pass, and this will not allow this to pass, and only what is gonna pass, okay? These, okay? So like this, okay? You got idea here, guys?
Yes,
yes. Is it clear? So some of the radiations that are produced by the star core or the inner layer of the star is absorbed by the star atmosphere. So here in that case, okay, we're gonna find something will be different when we use the spectrograph to analyze the light which is produced from the star. What will happen here? Actually, we are gonna, let's see here, guys. Here, that's for example, that the light, okay, bulb, this light bulb, okay, contain a tungsten filament that once become hot, it start to produce a certain light. Once you use the spectrograph will divide it into the 7 spectral colors as we can see. So that's the continuous spectrum which we have. But in case of the star, we're gonna imagine that the pulp is considered as the core of the star or the inner layer of a star. While we're gonna add a cool gases surround the bulb. These cool gases represent the star atmosphere. So the cool gas will actually absorb certain wavelengths or absorb certain amount of energy. So in that case, we're gonna find certain lights are missed, and that will lead to formation of black lines. You can see this, guys. Do you see the difference? These two black lines.
Yes.
Yeah.
Yes.
So here like this, okay, these two black lines, it means, okay, these gases already absorbing this, okay? So in the case, and in that case where I cannot continuous spectrum, why it's not continuous? Because there are some spectrum are missed or some spectrum are absorbed. So we call this absorption spectrum. We call it absorption spectrum, okay? Is it clear?
Yes.
Yep. So in that case, okay, in this situation, okay, and that means in case of stars, because already all the stars, they have this kind of cool gases around them, or they have a kind of atmosphere around them that will absorb certain wavelengths. But of course, these gases is not are the same in each star. They are different, or each star has different combination of gases in its atmosphere. So the absorption lines will not be exactly the same. The absorption light will differ from one star to another. That means, for example, this star is absorbed somehow part of the orange color, and part two, maybe another star absorb part of the yellow and part green, or maybe part of the red and part of green, and so on. So like this, we could use the absorption spectrum, okay? That means in case of emission lines, like what we use in the neon bulbs and something like that, no, we are gonna have another way. We will call this, okay, the absorption lights, okay, or the absorption lines. They will be found by comparing the different absorption lines, or comparing the different dark bands they are formed in the spectrograph. We could know what is the structure, okay, or what are found. That means I'm gonna compare the continuous spectrum to the absorption spectrum, and then I will know what are the missed, okay, part, and I then will know what gas is able to absorb this part, so I could know what is the structure of the atmosphere of that star. Is it clear here, guys?
Yes.
Yep. Okay. So here that the idea, or that's how scientists now are able to know the structure of most stars, okay, by this technique, okay, or by using or by analyzing their lights or emissions, okay, and so on. So today we are gonna stop at this point, guys. So we know what the star is made up of, and we know how we could detect the combination or the composition of a star by analyzing its color or the light which is emitted from it. And we know also that the color indicates certain temperature or indicate or regarding to the color of a star, we could predict is it hot or not hot, okay, star, and so on. Okay. Next session, inshallah, we're gonna know how science start to classify stars. Then we're gonna know what about the apparent magnitude and the real magnitude or absolute magnitude and something like this. Okay. Next session, Allah. So, anyone have any question regarding to what we explained today, guys?
No, thank you.
Everything is clear?
Yes, thank you,
Yes.
Mr.
Okay. So please study this part very well. Okay. And if you have any question, I'm waiting for your questions tomorrow. Thank you, guys, and goodbye.